So this is my playground submission for WWDC 2021, which is titled Silicon. My playground mainly aims to compare the fundamental difference between x86 and ARM, which is that x86 follows the CISC instruction set while ARM uses the RISC instruction set. Also, since Apple is now switching over to ARM and a new M1 just blew Intel out of the water, I thought that this would be quite an interesting topic to explore. The first page is an introduction to the concept of a CPU clock cycle. In general, this playground is meant to be a brief overview since the time limit is only 3 minutes, which I might have actually exceeded. All the graphics are created in code, so my zip file only came to about 1 megabyte. So as you can see here, the Intel Pentium processing the instructions here and generating an output with a nice animation. You can just adjust the slider here to adjust the CPU clock speed, and the animation adjusts accordingly. The second page is an introduction to assembly code in pseudo form. I only used CISC instructions here, as you wouldn't have to load and store the values before using them, so it's easier to grasp the concept. You can complete basic arithmetic using the instructions, and animations indicate the clock cycles and outputs. So let's just run this here. So as you can see, the values enter the RAM, then go to the CPU register, the instruction is processed, and you get an output. Page 3 is a comparison between RISC and CISC, as well as an introduction to RISC assembly code. This would differ from CISC, as you now have to store the values in memory first, then load them to the register before you can use them. You would normally have to store the result back into the register, but I left it out for the judges to save some time, although the function is still there and available to use. I also included these randomly generate functions, again just for the judges to save some time. So we've just got RISC code here, and we're going to randomly generate some CISC code. Let's run that. So as we can see, we just wrote the code for this, and this is being randomly generated, and we have our power used and RAM used here. Page 4 is a sort of encryption game. As you can see, the key is here. What you have is a list of math problems which you have to solve using assembly code to decode a message. If you use only RISC instructions, you can simulate the equivalent CISC instructions and vice versa. You can also use the cheat functions to simulate both, again just for the judges to save some time. So you wouldn't have to enter any code if you're using those. Let's just run that. So as we can see, we have a console output here with power and RAM used and the coded message output. So we only wrote code for the x86 CPU, and the ARM CPU is being simulated. So as you can see, some instructions take multiple clock cycles on the x86 CPU, whereas the ARM CPU takes 1 clock cycle per instruction. And then we have the messages decoded. So moving on to page 5, this brings us to M1 versus Intel. We have an i9-9900K and an M1. You can use these synthetic load functions to stress both CPUs and observe their thermals, clock speed, and power consumption. There's also a function to add water cooling to the x86 CPU, but let's run without that first. I was in a bit of a rush, so this isn't a true simulation, although this should give you a rough idea of how things are going now with the new M1 out. So as we can see, the temperatures rise quite rapidly. It thermal throttles and catches fire there. Let's run it with the water cooling function. So here we have the water block and coolant lines with a nice animation. It should still thermal throttle a little bit. There we go. But it will maintain a decent clock speed even though the temperatures are still a bit high. The M1 maintains a good clock speed and a good temperature here. And the power use is quite a lot less as well. I think the power difference is actually larger in real life than it's displayed here. Moving on to the next page, I wanted to try out CoreML since I've never actually used it before. So this is basically an image classifier using a user updatable model. You have to complete 3 drawings of 3 different types of Mac to train the model, the iMac, MacBook and Mac Mini. So let's just do that here. That's basically what an iMac looks like. As we can see, the neural engine of the M1 processing all of that here. Let's draw a MacBook, which is just a bad sketch of a laptop. But I guess it's fine for here. And you basically have to answer Mac trivia questions by completing a drawing. Let's draw a Mac Mini, which is basically a square. So which was the first Mac to have a Retina display? That was the MacBook Pro. And these lines turn green if the answer is correct and turn red if they are incorrect, which I think looks quite nice. So the final page is basically just a short sequence of animations showing how COVID alert notifications would work, as well as encouraging mask wearing and social distancing. I initially wanted to do this in AR, but Playgrounds and iPad just wouldn't run this at all, so I added this page at the last minute. Let's just run this here. This was meant to show how low-powered chips are being used to help reduce the spread of the coronavirus and in turn save lives. So there's the notification there. And there we have our i9 on fire again. So that basically wraps it up. I'm pretty happy with my submission this year. There are still some rough edges and I would want to make the values and assembly code a bit closer to a true simulation, but for 1.5 to 2 weeks I think it's not too shabby. I did have quite a few issues when making it. Playgrounds isn't exactly the most stable program out there. When I first moved everything from Xcode to Playgrounds, it ran very badly and crashed a lot, even with view results turned off. I then just copied and pasted everything into a new Playground file and it seems to work fine since then. It's quite odd, but it works, so I'll take it. So yeah, good luck to everyone else who applied and thanks for watching.